Welcome back, Professor Bright here, and we are going to talk about graphing sine and cosine functions via 5 points. And so this is a method to kind of graph sine and cosine in general. Last video we saw kind of the basic way to graph the sine and cosine using a table approach, inserting angles, getting or calculating the outputs of each function, and then putting those on a graph, right? Now, more often, you're not going to make a table of values every time you make a function, right? So you might remember you've seen linear functions, quadratic functions, and each of those functions you have kind of shortcut methods, right? So for example, linear function, you have a point and a slope. So you get a point, then you move according to the slope. Quadratic functions, you find the vertex, and then you can find another point off of the vertex, use axis of symmetry, graph it that way. Sine and cosine function in a similar manner. Really, when we want to produce a graph of sine and cosine by hand, we want to see really just one period. So don't feel like you have to sketch this thing forever and ever and ever. And in that single period, there's really 5 key points. And the key aspect is just it kind of helps us determine the curve. So as long as we have these 5 points, we're generally pretty set. And the 5 key points, as you can see in this picture below, are the local maxima. Okay, so I'll highlight that in yellow. The local minima, I'll highlight that in green. And then what I call centerline values. Book technically doesn't call them that, but it's just any place where if you just had the basic sine and cosine function, you'd be on the horizontal axis. Okay, so we want to get these 5 points, and with that, we have the graph. Now, graphically, yep, pretty easy to identify. I just did highlighting and boom, done, right? More generally, finding them algebraically, that could be a bit of a chore. And so here are some steps that we're going to go through. But first, I want to call your attention to one thing, and that is the general form, this ax or af of bx minus c plus d. So f is just standing for a trig function. So for example, we might see y is equal to a, insert a value for a, sine bx minus c and plus d. And a, b, c, and d are just numbers. So you can imagine there might be 3s, 4s, pi's in there, and that's just fine. So here are the steps that I use to find these key points. So I first kind of want to get in the right horizontal position. Okay, so to do that, I solve the inequality, 0 minus bx minus c less than or equal to 2 pi. So I sandwich effectively this inside component here, what I'm inserting into the function, my x values, right, between 0 and 2 pi, which is one period of the function. Okay, and so and with this inequality, it says solve it for x. Why do I want to do that? Because it tells me kind of the range of x. I guess normally it would give you one period, and then with this bx minus c, that's moving the period in some way. And so I just want to know what this new period is, or what this one cycle of the function is. I should actually be careful. The period is the width of the interval. Okay, and then wherever we shift to the 0, wherever the 0 shifts to, that would be our phase shift. Okay, so you can see 2 and 3 on the screen here. I'm just going to work through this on the screen here and then go and do 2 and 3. All right, so if I do that, I said in this case, I would do 0 less than or equal to the x over 2 minus pi less than or equal to 2 pi. And I want to solve this for x, so I would add pi to all 3 components. And if you need to review how to solve compound inequalities, please do. I am not going to in this video. So x over 2 less than or equal to 3 pi. And then to solve for x, I would multiply the middle component by 2, which would result in me multiplying all components by 2. So at the end of the day, I get 2 pi less than or equal to x less than or equal to 6 pi. Okay, so that would be one period of this particular function, or one cycle of the particular function. And then from here, this is a width. So I'm just going to make a comment here. So the width is 4 pi, and that's the period. Okay, and the other comment that I'll make is that this 2 pi, notice that originally a period would have started at 0. Now it starts at 2 pi. So I'm going to also say that phase shift or simply put, the amount of horizontal shift is 2 pi. Okay, so I shift to the right by 2 pi. All right, so then step 2. So this is all step 1 yet. So step 2 says take the interval width. Okay, so I found that width, or the period, to be 4 pi, and divide that into 4 pieces. So I take that and divide 4 pi into 4, and so I get pi, and this is the increments. Okay, so when I'm making my graph, I'm going to enumerate along the horizontal axis by pi. Okay, and then it says increment in step 3, increment from the starting place by the value from step 2. So okay, so I start at 2 pi, and then so that would be the x-coordinate of my first key point, and then I would increment, so I would add pi to that, so I get 3 pi, add pi to the 3 pi, I get 4 pi, 5 pi, and then I would go to 6 pi, and I end there because that's the end of my interval. Okay, so each of my key points in coordinate form are going to start with this form. Okay, so 2 pi comma something, I don't know what the y value is, 3 pi comma something, 4 pi comma something, 5 pi comma something, 6 pi comma something. Okay, so I found the x coordinate, so I have the right horizontal positioning. Okay, now I need to get the correct vertical positioning. Okay, and so for this, you can read the steps here, but I'm going to make a table of y values for each of the 5 points, and then kind of initiate, so start the any maxima to set those to 1, any minima to -1, and centerline values to 0. And then again, this would be dependent on the parent function, so it would follow that sine pattern or cosine pattern. Okay, and then add a column, multiplies the initiated values by a, and then add d. Okay, so let's just kind of take a glance at this. So for my first key point, okay, so imagine if you want to insert the x values, you sure can. Sometimes I do, sometimes I don't. 3 pi, 4 pi, 5 pi, oops, and 6 pi. Okay, and now this is a sine function, right? So sine starts at its center line, so I would put a 0 in for the center line value, and then it would go up to its maximum, and then down to its, and then center line, minimum, center line. Center, max, center, min, center. Okay, so now, according to these steps, right, I make another column. So these aren't technically the y values, but I would start them at that, at these values, and then I would do, so let's just do y like this, and then I multiply those y values by a. So a here is -2. Okay, so I do 0, -2, 0, +2, 0. Okay, and then in the next, I take whatever I had before, and then I add on d. And d is 1. Okay, so I do 1, and then add 1 to that, -1, 1, 3, 1. Okay, and so now these are actually my y values. Okay, so for instance, I would have the key point 2 pi comma 1, and then down here it might be 5 pi comma 3. Okay, so I just need to turn these each into points. And with that, I am able to make a graph. Before I go on, I should also mention that D I commonly refer to as a centerline shift. Textbook doesn't call it that, but I have seen it referred to that. And A, if you take the absolute value here of A, we talk about that as the amplitude. And amplitude is simply just the distance, that's why we have absolute value, distance from center line to maximum or center line to minimum. Okay, so now we're ready to sketch the period of this thing, or one period of this thing. Okay, so I'm going to make a graph. Okay, I know, let's see, I'm just going to make some marks. 2, 3, 4, 5, 6. Okay, and okay, so I need to figure out horizontal positioning first. Okay, right. So I said before that this thing is between 2 pi and 6 pi. Okay, so I have 6 marks. That was a happy coincidence. And so I might call this pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. Now, this was a happy coincidence as well because I had found that my increment is pi. So typically what I would do is I would start at my starting horizontal position and then add pi to get to the next one, okay, or add that increment, okay? We'll go through another example here briefly to show all that. All right, so now I have it right horizontally and vertically. I know the minimum is -1, and then the maximum is +3. Okay, so now it's as simple as let's plot the points and see what we get. So 2 pi, comma 1, 3 pi, comma -1, 3 pi, comma -1, right there, 4 pi, comma 1, 5 pi, comma 3, and 6 pi, comma 1. Okay, so in all, I get something that looks like this for one period. Now, technically, these are periodic functions, so you should kind of go beyond them with arrows just to indicate that they're pattern repeats. But that's all we have to do for graphing sine or cosine by the 5 key points. Okay, so this procedure can be generalized. Here we did sine, down below we have cosine. So we'll do one more example here, running through it a little bit quicker. Okay, so let's find the horizontal. Okay, so I first take that input, so 3x plus 2 sandwich, or 2 pi, sandwich that between 2 pi and 0, and then solve for x, right? So subtract 2 pi minus 2 pi less than or equal to 3x less than or equal to 0, and then divide by 3, so x less than or equal to 0, and then less than or equal to -2/3 pi, okay? And then, so that's one period, and then the increments, right? I take this interval width, this one appears negative, but again, I'm just thinking the width, so I would actually just do absolute values. So take 2 pi over 3 and divide that into 4 pieces, okay? Could be a little tricky with the arithmetic here. You end up with pi over 6, okay? So when I make my graph, that's the increments that I'm going to use along the horizontal axis. All right, moving on. So that's the horizontal positioning, vertical position, and actually if I wanted to, I could say, okay, make my table of x values. So I would start at -2 pi over 3. That's also my phase shift. And then I need to add pi over 6 each time. The arithmetic here could be a little annoying to work with, but you verify on your own as needed. And then we get pi over 3, pi over 6 negative, and then our last is going to be 0. Okay, so I have the horizontal positioning. Okay, vertical positioning, that's where I kind of start with that y value. When for cosine, the general pattern would be maximum, 0, or sorry, maximum, center, minimum, center, maximum. Okay, and then I need to multiply that by 1/2 for that a value. So 1/2, 0, -1/2, 0, half. And then lastly, I want to take that and subtract 1/2. So that'd be 0, -1/2, -1, -1/2, and 0. Okay, so in all, right, I have the first and last columns as my x and y values respectively. So then making a sketch of this thing, okay, all my x's are negatives, and I'm going to increment by pi over 6. So this is negative pi over 6, negative pi over 3, negative pi over 2, negative pi, 2 pi over 3. Okay, that would be all I need. And then vertically, right, I go down to -1. So I'm just going to do here to kind of exaggerate it a little bit. Okay, and then with that, I can plot my points. So -2/3, 0. Oops, let me get a different color. Minus pi over 2, -1/2, something like that. and then pi over 3 minus 1, boom, and boom. So I get something that looks like this. Okay? And so, again, 5-point method can be a very quick way to graph these trig functions, and eventually we'll see another method as well.